Go ahead and get started. For today's session, um, we are going to be covering the linear and nonlinear systems of equations. For those of you who are for the Math 1324, um, if you want to go ahead and click on the link that's on your chat already, if you're here for Math 1324, you can. But Mr. Sasi is running a little late, so if you want to stay here and watch this system for a while, you can do so. Okay, we'll let you know when you can go ahead and click on the Math 1324 link. All right, so let's go ahead and get started.
Papi.
Okay, I'm sorry about that. Let me go ahead and get started. So, what is a linear system? So, linear systems, I hope you've know by now, we're going to be talking about lines, right? And the most common way that we see the lines is in standard form or general form, which is in ax plus by equals c. So these are lines that are graphed. Now, a linear system means that we're going to be looking at more than one line. Okay, and the solution for these linear systems is where we have an ordered pair that satisfies both of the lines. And what does this mean? It means that where these two lines intersect. Okay, that's what that means with this ordered pair. Now, a solution set is the the points that make both equations a true statement. So the best way to see this is just by examples. All right, so um, a system can be um, defined as a linear equations, or we're also going to be looking at nonlinear equations. What does this mean? So the nonlinear equations means that maybe we're going to look at a graph where we have a line in a circle, okay, or a parabola in a circle. So these are two equations that are not nonlinear, okay? Now, there's several ways that we can use to solve where these graphs intersect. And the three ways that we're going to be looking at is substitution, elimination by addition, and by graphing. Okay, so the solution again is where these graphs intersect. All right, so here are some pictures to find the solutions for systems. So if you look at the first one here, the first one we have two lines, and these two lines intersect, right? We have at the where these two lines intersect, they intersect at this point, 2, 0, right? So for the first one here, the solution is this ordered pair, 2, 0. Okay. For the second graph here, we have a nonlinear graph, which is a parabola, and then a line as well. If we see here, we're going to have a solution set because this line crosses this parabola at 2 points, right? At 2 places. So here, the solution set for this one is at 0, -1. That's where it crosses one time, and then at 2, 1, where it crosses at the other point. Okay, and if we look at this last example, we have a line and a parabola, but if you see here on the graph, these two equations never intersect. So then for the solution for this one is no solution, or you'll put on your homework, DNE does not exist. Okay. All right, so let's determine whether each ordered pair is a solution of the system. So right now, on this one, we're not solving. What they want us to do is we want to verify is that this point is a solution of the system, right? And for us to determine if the point is a solution of the system, it has to satisfy both of the equations, right? So the way to do this is we are going to plug in. So the first one, the first equation, we'll take the first equation, 2x minus y equals 4. And we're going to plug in this point, the 0, -4. So we plug in and substitute 0 for x, -4 for y. And then we're going to go ahead and simplify. And when we simplify, we see that we get a true statement. 4 is equal to 4. So this point is a point that lies on this line. Um, now, um, for it to be a solution of the system, though, it has to also satisfy the second equation. So let's go ahead and do it again. let's substitute 0, -4 into the second equation. And if you see, when we plug in 0 for x, -4 for y, we get a false statement. -4 is not equal to -9. So since this point only satisfied one of the equations, it's not a solution for the system. It has to satisfy both equations for it to be a solution of the system. So again, on this answer, 0, you would put in 0, -4 is not a solution to the system. Let's try the second example. Um, 1/2 and -2. Okay, so again, I'm gonna test it on the first equation, 2x minus y equals 4. Replace x with -1/2. Replace y with a -5. And when I simplify, again, I get a true statement. 4 is equal to 4. But again, for it to be a solution of the system, it needs to satisfy the second equation. And when I do that, when I replace -1/2 for the x and -5 for the y for the second equation, you see I get a true statement. -9 is equal to -9. So hence on this problem, or this point, -1/2 is, -1/2, -5 is a solution of the system. Yes? Okay. All right. So let's look at ways to solving systems of equations, right? So right now we are dealing with two linear equations. How do I know that these equations are linear? All I have to do is look at the exponent for the x, right? So since the exponent has a 1 for both equations, I know that I'm dealing with lines. So the two methods that we're going to be looking at to solve um, linear systems or systems of equations is by the substitution method and the elimination method. Okay. Now I like both of them, but um, you'll see which one is the best one for you. Okay. Now we'll look at the first one, the substitution method. The substitution method is just how the name implies. Um, to solve, we're going to choose one of the equations. In this case, I just chose the first one, the x plus y equals 4. And what I'm going to do is I'm going to solve for one of the variables. Okay. And in this case, I solve for x, right? So to solve for x, all I had to do was move the y to the other side. And I did that by subtracting y on both sides. So I have this new equation, x equals 4 minus y. But again, just like the name says, substitution method, I'm going to substitute this answer for x, and I'm going to substitute it into the second equation, okay? So the second equation is x minus y equals to 2. Everywhere I see x, I'm going to plug in this, 4 minus y, okay? All right, and when I do this, um, I'm just going to go ahead and solve for y again, okay? So we have minus y is a minus 2y, okay? I'm going to move the 4 to the other side by subtracting 4 on both sides, and I get minus 2y is equal to minus 2. Then I divide by a negative 2 on both sides. And when I do that, I have y equals 1. So I have one of the... All right, so y equals 1. So now to get the x value, all I have to do is substitute this answer back into the red one because I already have it solved for x, yes? So I have, I wrote the equation again. So x plus y equals 4. I replace the y equals to 1. Again, if I would have used the one in red, if I plug in the 1 here, I would have had just 4 minus 1 gives me the 3, right? So this is an example of using the substitution method. Now let's look at the elimination method. The way the elimination states is just how the name says. What we want to do is we want to eliminate one of the variables, and we're going to eliminate it by adding, okay? Okay, so we're going to choose a variable to eliminate. So let's eliminate the y's. And the reason why I want to eliminate the y's is because I see that just by adding the two equations, I don't have to do anything other than just add them, the y's would go away, right? So let's go ahead and do that. I have x plus y equals 4 and x minus y equals 2. So when I add these two equations together, I see that I have um, so I have 2x is equal to 6. The x plus x is 2x, 4 plus 2 is 6. Now to solve for x, I'm just going to divide by 2 on both sides. So x equals 3. Uh, um, okay. So now to get the y value, okay, I'm gonna replace it into either of the two equations. It doesn't matter which one. So in my case here, I picked the first one, x plus y equals 4. So um, I know that x is 3, so I have 3 plus y equals 4. So I'll subtract 3 on both sides, and I'm gonna get y is equal to 1. So my solution set here for both of them is 3, 1, right? The x value for 3 and the y value for 1. It gives me a true statement for both. Yes? Okay, so now let's go ahead and solve this next system of equations. Again, we are still dealing with lines, okay? And let's use any method. So for this particular one, let's go ahead and use the substitution method. So again, I'm going to pick one of the equations, and in this case, I picked 2x plus 3 equals y, and I'm going to solve for, well, actually, it's already solved for me, right? I have it's equal to y. So the problem is helping me out. It already solved for one of the variables. So now all I have to do is replace this y value, this 2x plus 3, everywhere I see y on the second equation, right? So the second equation is x plus 2y equals minus 4. Again, everywhere I see y, I'm going to plug in the 2x plus 3. So when I do this, let's go ahead and simplify. The first thing I need to do is I need to distribute the 2. So when I distribute the 2, I get 2x, x is equal to 4x plus 6 equals to negative 4. Let's combine our like terms. So x plus 4x is 5x. Move the 6 to the other side by subtracting 6 on both sides. So minus 4 minus 6 gives me a minus 10. And to solve for x, all I have to do is divide by 5 on both sides. So when I divide by 5 on both sides, I see that x is equal to negative 2. So now to get the y value, all I'm going to do is going to replace this to that first equation, right? Um, so I have 2x plus 3 equals y. Everywhere I see x, I'm going to plug in negative 2. So 2 times negative 2 is a negative 4. Negative 4 plus 3 is a negative 1. So y is equal to negative 1. So my solution set for this problem is x equals negative 2 and y equals negative 1. And again, what this point means is where this point satisfies both of these equations. Both of these equations, okay? Or in other words, where these two lines intersect. All right, let's look at this second example. And again, the second example, I think we should use a substitution method again, because on the second one now, they solve for one of the variables already for us. Or they have it in slope-intercept form, right? Y equals 2x minus 3. So let's go ahead and use the substitution method again, okay? So I'm going to choose the first equation, 3x minus 2y equals 7. And everywhere I see y, I'm going to plug in this 2x minus 3, right? So let's go ahead and do this. So we have 3x minus 2 times 2x minus 3 equals to 7. Let's go ahead and distribute the negative 2. So negative 2 times 2x is negative 4x. Negative 2 times 3 is a positive 6. Let's combine our like terms. 3x minus 4x is a negative x. Move the 6 to the other side by subtracting 6 on both sides. So 7 minus 6 is 1. Okay, so the last thing I want to do is, since I want a positive x, I'm going to multiply by a negative on both sides. So this gives me x equals -1. Now to get the y value, it's called something called back substitution. I pick any of the equations. Since I use substitution, doesn't matter which one I pick. And I'm just going to pick the second one. Okay. So for the second one, y equals 2x minus 3. I'm going to, everywhere I see x, I'm going to plug in that -1. So 2 times a -1 is a -2. -2 times a -2 plus a -3 is a -5. So my solution set here is -1, -5. Okay. All right. So let's see here. Let's look at this second example, our next example. Solve the system of equations using any method. So on this one here, to solve for any of these variables, we're going to get fractions. So I think the best method to use, and so we can practice, is let's use the elimination by addition method. Yes. So if we want to eliminate a variable, let's say that we want to eliminate the x value, okay, what we want to do is we want to have the same quantity with opposite symbols here uh, to be able to, when we add them together, they cancel out or they give us 0, right? So if I see here that the least common multiple between 2 and 5 is 10. Now, and I see the least common multiple because 2 can never become 5, and 5 can never become 2. So the least common multiple, since the two numbers are already prime numbers, is just by multiplying these two together. 2 times 5 is going to give me the 10, right? So this is the least common multiple that these two variables share. So what I'm going to do is I'm going to multiply. All right, so we're going to multiply 5 to the first equation and 2 to the second equation, okay? So let's do this. So on the first one, on the first equation, I'm going to multiply it by 5. And when I do this, I get 10x minus 35y. All right, now I'm going to do multiply 2 to the second equation. And when I do this, I get negative 10x plus 6y equals 14. So if you notice here for the x term, we have two terms that are of the same value but opposite signs, right? So now I'm going to add these two equations together. And when I do this, you see that 10x minus 10x gives me the 0. I'm going to add negative 35y with a plus 6y gives me a negative 29y. And 15 plus 14 is 29. So here, 0 minus 29y is just minus 29y. So to solve for y, I'm going to divide both sides by a negative 29. I get y equals 1. All right, now to get the x value, I'm going to do back substitution, and I'm going to pick any of the equations. It doesn't matter which equation you pick. So in my case, I'm going to pick the first one. It doesn't matter. 2x minus 7y equals 3. And everywhere I see y, I'm going to replace it with -1. So here, -7 times a -1 gives me a positive 7. Subtract 7 on both sides. So -7 plus 3 gives me a -4. Divide by 2 on both sides. X equals -2. So the solution set for this system is -2, -1. Okay. All right, let's look at this next example. Um, and again, I think what we need to do is let's go ahead and use the elimination method again. And let's go ahead and eliminate the x value. But on this one, do you see here that I can make the 2 into a 4? The 4 is a multiple of 2. So on this particular example, I'm only going to have to multiply one of the equations with a number. And since they're already opposite signs, I don't have to worry about the signs. So in order for me to get the first equation equal to a 4, I see that I just need to multiply a 2 to this equation, right? So I'm going to multiply a 2 to the first equation. And when I do that, I'm going to get 4x minus 10y equals 12. Now I'm going to add it to that second equation. So let's go ahead and add the two equations together. And when I do this, 4x minus 4x gives me 0, minus 10y plus 10y gives me 0, and 12 minus y gives me negative 11. Oh, now here, what we have is we have a false statement, right? 0 is not equal to negative 11. So since I got this statement, since I got a false statement, what this is telling me is that these two lines never intersect. They don't share anything in common. They have no solution. So whenever you have this scenario here, where you have a false statement when you're doing the um, elimination method, this means that we have what's called an inconsistent system, meaning that these two lines do not intersect and there is no solution. All right, let's try now a word problem here. So we have the given amount of an annual interest is earned from a total of $9,000 investment in two funds paying simple interest, right? And solve a system of equations to find the amounts invested for each at a given rate. Okay, so we're going to invest a total of $9,000 and we're going to invest it in two funds. One is going to give me a rate of 2%, and the other one's going to give me a rate of 6%. Okay, so for explanation purposes, again, we're going to call them the funds just A and B. Okay, the one that gives me the 2% for A and the 6% for B. And I know that when we add these two funds together, they have to give us a total of $9,000 investment. Okay, so let's go ahead and start um, writing our equations. So the first equation that we can see here is that investment A plus investment B should equal to $9,000. Okay. Now the other one here, let's use a simple interest formula to find the other equation. So it says that we have an annual interest of 380 for both of these rates. So what this means that if I invest at 2% for the A, so again, that's you can think of this as the rate times the quantity, okay, for the A, and plus zero point zero 0.06 times B. Again, I converted the 2% into decimals. This should equal my annual interest, $380. Okay. Okay. Now that I have these two equations, I can solve using either the substitution method or the elimination method. Let's see here. So I think the best way to do it is to go ahead and do the elimination method. And first, let's get rid of the decimals. So what I'm going to do is I'm going to multiply by 100 to the second equation. That way I can eliminate these decimals and I don't have to be dealing with decimals and bring out my calculator. All right. So when I do that, when I multiply 100 to the second equation, I have this nice simple equation. 2a plus 6b is equal to 3,800. So now I have these two equations that have no decimals. And let's go ahead and eliminate the a. So to eliminate the a, I need to have a negative 2a here. So I'm going to multiply negative 2 to the first equation. So when I do that, I get negative 2a minus 2b is equal to a negative 1,800. I'm going to add the two equations together. When I add the two equations together, negative 2a plus 2a cancels out or eliminates. Minus 2b plus 6b is 4b, and negative 1,800 plus the 3,800 gives me the 20,000, right? So here, divide by 4 on both sides. 20 divided by 4 is a 5, so b is the 5,000, yes? So I have one of the investment values, 5,000, but I know I invested 9,000, so I know what the value of A is, but if you don't see it, okay, what we can do is we can do back substitution, A plus B had to be equal to 9,000. I know that B is 5,000. So to solve for A, I just have to subtract 5,000 on both sides. So 9,000 minus 5,000 gives me the 4,000. Okay. All right. So now let's look at the nonlinear systems. Again, the examples that we saw right now, all of them dealt with just lines, where the two lines intersect. But what a nonlinear system is a system that deals with um, something that's not a line. For instance, like the second and third example, they both have a parabola on there. They're nonlinear systems. Okay. So for these nonlinear systems, again, we can use any method to solve. So let's go ahead and use the elimination method on this one. And the reason why we want to use the elimination method is because we see that if we just add equation 1 with equation 2, we're going to eliminate the y's. Now, again, if you see here, equation 1, the x has a square in it, so I'm dealing with something that is a parabola. The second one is a line, but this is considered a nonlinear system. All right, so when we add the two equations together, the x squared minus y equals 0 plus 4x plus y equals 0, we're going to get x squared plus 4x is equal to 0. Okay, we eliminated the y. Now we need to solve for x. Now what we can do is we can use our quadratic formula, we can factor, and I think that's the best way to solve this particular problem. If we want to solve for x for something that has a quadratic on this particular equation, okay, let's just go ahead and factor. So we have x squared plus 4x is equal to 0. For I see that these two terms share an x. So if I factor out an x, we have x times x plus 4. So when I have a product that the answer is equal to 0, this is telling me that in order for me to get 0, either x is equal to 0 or the x plus 4 is equal to 0. So here we have two solutions. X can either be 0 or x can either be negative 4. So what we're going to do is we're going to plug these two x values into any of the two equations to get our y value. Okay, so let's start with the easy one, with the line. 4x plus y equals 0. Let's replace x with 0. So 4 times 0 is 0. So y is equal to 0. So when x is equal to 0, y is equal to 0. That's one of our solution points. Okay. Um, let's try the second equation, or the first equation, x squared minus y equals to 0. Um, what I'm going to do is I'm going to oh, I'm using the x, sorry. So I'm just going to use the other x. And I can use the same equation. So x equals negative 4. Now let me use negative 4 again to the same equation. I can pick any of them, but I'm just to keep it standard, I'm going to keep on using the same equation. I'm going to pick 4x plus y equals 0. So when I do this, 4 times a negative 4 is a negative 16. To solve for y, I'm going to add 16 on both sides. So y is equal to 16. Okay. So here we have two solution points. We have a solution set where one is 0, 0, and the other one is negative 4, 16. Yes? And again, we have a parabola, and my line is crossing 2 points in my parabola. All right, let's try this next example. We have x minus y equals negative 5, x squared minus y equals negative 6. Okay, so let's use the elimination method again. And I want to get rid of the y's again. But if I see here, both y's have the same sign. So they have the same value. Both of them are 1. But in order for them to be opposite signs, all I have to do is multiply one of the equations by a negative 1. Yes? So what I'm going to do is I'm going to multiply negative 1 to equation 1. And when I do that, I get negative x plus y equals 5. So now I can add these two equations and my y's are going to get eliminated. So when I add x plus y equals negative 5 with x squared minus y equals negative 6, when I add these two, see my y's cancels, but I get x plus x squared is equal to negative 11. Since we have a quadratic again, let's move everything to one side, set it equal to 0, and let's put it in standard form where we have the in descending order the coefficients, right? So here we have this x squared plus x plus 11 is equal to 0. We have a quadratic. Again, we have a lot of um, arsenal under our belt in order to solve for this. We can use our quadratic equation, we can factor, we can complete the square. Okay, there's several things that we can do, but let's go ahead and practice using our quadratic equation to solve for this one. So when I use my quadratic equation, again, this is negative b plus or minus the square root of b squared minus 4ac all over 2a. Here, you see in my problem, a was 1, b is 1, c is 11, and this is what I plugged in. Um, I see that I'm going to have a negative under the square root, and this is going to give me an error. So since I got an error, what this is telling me, we have an inconsistent system. And what does an inconsistent system means? It means that these two graphs do not intersect. They don't have anything in common. So the answer would be no solution. Okay. All right. Ooh, let's try this one. This one is interesting. I kind of like this one. If you see here, we have our dealing with a nonlinear system completely because the first one, if you recall, this is the equation of a circle, right? We have a x squared plus y squared is equal to 25. This circle, the center is at the origin, 0, 0, didn't get shifted. There's no h and k value. And my radius here is 5, right? And then the second equation, we are dealing with a quadratic again. All right, so let's go ahead and use any method. And I think the best method to use is, again, the elimination method to solve for this one, right? So let's go ahead and let's eliminate the x, yes? So in order for me to eliminate the x, I need to have a negative 3 here for this first equation. So I'm going to multiply the first equation by a negative 3. Now, I haven't mentioned this, but please keep in mind, when I'm using the elimination method and I'm multiplying a number in order to eliminate one of the variables, make sure you multiply this number to the whole equation, okay? One of the most common mistakes students make is that they only multiply it to the first half and they forget to multiply it to the other half or with the other or on the other side of the equation or the equal sign, okay? So please don't forget that when we're multiplying a number, we got to multiply to the whole equation, to both sides of the equation, because we don't want to unbalance it, okay? So let's go ahead and do this. And then you see here, when I've been writing them, I multiplied to the whole equation, to the x squared plus y squared is equal to 25. So when I multiply negative 3 to this whole equation, I get a negative 3x squared minus a 3y squared is equal to a negative 75. So now I'm going to add the two equations together. So here, negative 3x squared plus a 3x squared is going to get eliminated. I'm going to get a 0. So when I add negative 3y squared minus 16y, I get a negative 3y squared minus 16y. A negative 75 plus 0 is a negative 75. I have another quadratic, okay? But here, now my axis of symmetry is the y value. Instead of the x um, sorry, instead of the y-axis is now the x-axis. That's my axis of symmetry. So it's like a parabola on its side, right? So just to make it nicer, let's move everything to one side. So we have negative 3y squared minus 16y plus 75 is equal to 0. Again, we can factor this or use our quadratic equation. Let's go ahead and use our quadratic equation again. So here again, I'm using my quadratic equation. A is equal to negative 3, B is equal to negative 16, C is equal to 75. Substitute these values into the quadratic equation, and I'm going to get two answers. Here, I have negative 25 over 3 for y, and I have 3 for the other y. Okay, so we're going to do back substitution. We can pick any of the two equations we want. It doesn't matter which one we pick. Okay, so in my case, I'm going to pick the first equation, the circle one, right? The x squared plus y squared is equal to 25. So first, I'm going to pick the 3. Um, when I pick the 3, I have x squared plus 3 squared is equal to 25. 3 squared is equal to 9. Subtract 9 on both sides. So 25 minus 9 is 16. Take the square root of both sides, and I have here plus or minus 4 for an x. So here I have two answers. I have 4 is equal to 3 and negative 4 is equal to 3. Okay. Now don't forget, I had another y value, right? I had a y value for negative 25 over 3. And when I plugged this in, you saw that if I take the square root, I'm taking a square root of a negative number. This is going to give me no real solution. So this value here does didn't does not intersect the point or the circle or the quadratic. So I'm not interested in that. But I do have a solution here where this parabola does cross the circle at 2 points, at 4, 3 and negative 4, 3. So that would be my solution. My solution would only be um, these 2 points, 4, 3 and negative 4, 3. That should be a 3, not a 2. Okay. All right. Let's go ahead and solve this system now. We have xy minus y equals 0. And then we have 3x minus 6y plus 17 equals 0. Oh, this one looks hard, but we can do this. So if we see here, let's go ahead and use the substitution method. Since we have an equation, we have nxy, we have the values joined together. Let's use substitution method. So I'm going to do is I'm going to take the first equation and I'm going to solve for x. Okay, so to solve for x, I'm going to add 1 on both sides. And then I'm going to divide by y on both sides. And when I do that, I have x is equal to 1 over y. Yes? Um, so if you see here, we have a rational expression, right? So we have a rational expression with a linear line. All right, let's go ahead and substitute. Since I solved for x on the first equation, I need to substitute this y value, this x value into the second equation. Okay, so I'm going to substitute this into second equation. Let's go ahead and do that. So we have 3 times a 1 over y minus 6y plus 17 is equal to 0. Let's go ahead and simplify by distributing that 3. So we have 3 over y is equal to minus 6y plus 17 is equal to 0. Okay. Let's get rid of the fraction by multiplying by y to the entire equation. So when I multiply by y to the entire equation, I get 3 minus 6y squared plus 17y equals 0. Okay, so here, if you see here, we have a quadratic equation. And let's put it a little nicer. Let's put it in standard form. Let's reorder it and put it in this way. Minus 6y squared plus 17y plus 3 is equal to 0. Okay, so let's go ahead and use our quadratic equation again. And again, just to review, my A value is negative 6, my B value is 17, my C value is 3. And when I solve for my quadratic equation, again, I'm going to get two answers again. I have y equals negative 1 over 6 and y equals 3. We're going to use back substitution. Since I used the substitution method, again, it doesn't matter which of these two equations I pick to use my back substitution. Again, I'm going to pick the first one. They're both equally easy. So we have x minus y equals 1 equals 0. So first, let's um, solve when y equals negative 1 over 6. So we have x times negative 1 over 6 minus 1 equals 6. Multiply the x, we have negative x is equal um, negative x over 6. And then let's add the 1 on both sides. This is going to give me equals 1. So to solve for x, I'm just going to multiply by negative 6 on both sides. So x is equal to negative 6. Okay, so I have one solution point. Now let's get the next one. Let's use y equals 3. Let's substitute the 3 into the y. So we have x times 3 minus 1 equals 0. Let's add 1 on both sides. And we have 3x is equal to 1. Divide by 3 on both sides. We have x is equal to 1/3. So we have two solutions here, two solution points, right? So here, our two solutions are when x is equal to negative 6, y is equal to negative 1 over 6. And when x is equal to 1/3, y is equal to 3. Okay. All right. So again, this is how to solve systems of equations, whether they're linear or nonlinear. You can use these two methods, the substitution method and the elimination method. You saw that we started off that we can also graph them to solve. Now, when graphing, we don't use the graphing a lot because to determine where the two lines intersect exactly is very hard to do. So we like to do them algebraically. But there's one thing that does help us if some of you all have a graphing tool, what you can do is you can graph both of the equations just to see if the two equations are going to intersect. That's what graphing allows us to see right away. If you notice on the examples that I gave you, if the two graphs don't intersect, then we don't have to do any work. We know that there's going to be a no solution because they're inconsistent systems, meaning they don't intersect. It can tell us right away. And then now that we know that they don't intersect, we can just say that there's no solutions. But if we see that on our graphing tool, the two graphs are going to intersect, then you can do it algebraically so you can get the right answers. You can use both the elimination method and the substitution method. Again, pick the one that's best suits you, the one that you love the most. Learn how to do both of them. Okay, both of them. Some methods are better to use with others. Okay, especially when they solve one of the variables for you already. The best way to use is always the substitution method. Okay, so again, I am finishing a little bit early. This concludes the session for today. Again, if you are joining me right now, you can download this presentation right now by clicking on the on the icon that has a box with a arrow pointing into it. You can click on it and you can download the presentation. Again, if you missed this presentation, this will be uploaded to our EPC YouTube channel later on today. Again, thank you for joining me. Good luck in your summer classes. We're almost done. I'll pass it back to our presenter.
Thank you, Mr. Carrizales, for your wonderful presentation. We do want to remind you all about your previously recorded sessions, which are available on our YouTube playlist. Today's session will also be available on that playlist later on today. Also linked is a short survey to help us improve our TVE sessions. Please take time to fill out the survey. Before you leave, I want to share the TVE sessions that we will have next week. We'll be back with Happy Math Hour next week at 11, where Math 1314 will be covering basic matrix operations, and Math 1324 will be looking at exam 4 review. At 1 p.m. today, we will have student success, premiering with EPCC Writing Center with Ms. Vanessa Zuniga. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use your chat box or mic. We hope to see everyone again for Happy Math Hour.